Okay, I grabbed a couple problems from the homework, and these might not be the exact answer or the exact problems that you have, but they should be close enough to do what we're trying to have it do. Hopefully you can read what I wrote here. Okay, it says determine whether each value of x is a solution of the inequality. Select all that apply. So the inequality is x squared minus x minus 12 greater than or equal to 0. And then the four choices are listed here. So if you've gone through the answer, or if you've gone through the ebook and the notes, you should know that when you have a polynomial inequality, that what you want to do is factor. So I have x minus 4 times x plus 3. So that means x equals 4 and x equals negative 3 are critical points. So there's like a dash line, vertical dash line here, and a vertical dash line here. So what that does on the number line is create for us three regions: in this area, in this area, and this area. So what you need to do is you need to pick a point in each region. So in this region, greater than 4, I'm going to pick 5. I pick 5, and what this is showing is put it in the inequality. So 5 minus 4 yields a positive number. 5 plus 3 yields a positive number. A positive times a positive is a positive. So anything bigger than 4 that we select will make this inequality positive, and that's what we're looking for. We're looking for values of x that are greater than or equal to 0. Now, the other region is between minus 3 and 4. So you can pick any value between minus 3 and 4. So let's try 1. So I put 1 in here. 1 minus 4 is a negative number. 1 plus 3 is a positive number. A negative times a positive is a negative. So I even showed another one just so you could see. But anywhere between negative 3 and 4 is negative. That means the numbers I pick will make this side of the inequality less than 0. So that means the inequality is not satisfied between here and here. Now, I need to test the region to the left of negative 3, the other 0 of the inequality. So I'll put in negative 4. So if I put negative 4 in here, negative 4 minus 4 is negative. Negative 4 plus 3 is negative. A negative times a negative is a positive. So any number I pick less than negative 3 makes the inequality positive. So that's what I'm looking for. I'm looking for values that make this positive. So now I go back and look at the answers. 0 is not an answer because anything in this region between minus 3 and 4 makes the inequality 0. 5 is way out here. It just happens to be the number we tried. So yes, that is a solution. Now, negative 3 is a solution because negative 3 is a 0. And since it's greater than or equal to 0, then that can be a solution as well. And negative 1 is between negative 3 and 4. And we know that that makes this negative. So negative 1 is not a solution. All righty. Let me see. I got to figure this out. Let's make this go down to the next one. Here we go. All right, I picked another one. It said, oh, I see what it's doing. This says solve the inequality and graph it. So here's my inequality. And we always want to be comparing with 0. So what we want to do is subtract 4 from both sides. So we end up with this polynomial inequality. So just like the other one, we're going to factor. So we factor into x plus 4, x minus 1. So that means x equals 1 and x equals minus 4 are critical points. So you can see that I graphed them here and I drew these vertical lines. Again, I've created 3 regions for myself. And all you got to do is pick a value in that region and test it in this factored form of the polynomial. It's easiest to test when it's factored. Also, when you're picking values to try whole numbers. And if 0 is available, always use 0. So in the region greater than 1, I picked 2. So 2 plus 4 is a positive number. 2 minus 1 is a positive number. A positive times a positive is a positive. Notice I'm circling the conclusion. So any number we pick bigger than 1 is going to be part of the solution set. Notice that it's not or equal to, so we would not include 1 as part of the solution. So that anything we pick bigger than 1 would be in our solution. So we can write it like this, and then we can show on the number line a circle at 0, and then we kind of like darken this area. If I test the region between minus 4 and 1 with 0, 0 plus 4 is a positive, 0 minus 1 is a negative, a positive times a negative is a negative. So any number in this region makes this inequality negative, so it's not part of our solution. The last region to check is out here, less than negative 4, so I selected negative 5. If I stick negative 5 in here, I get a negative. If I stick negative 5 in for x here, I get a negative. A negative times a negative is a positive. So any number smaller than negative 4 will make this polynomial greater than 0, so it would be part of the solution set. So we put a circle at negative 4 and shade everything to the left, or if we want to write it using interval notation, we would write it like this. Now, that's a couple examples with a simple polynomial, but things get more complicated when we have a rational polynomial. So again, just like with regular polynomials, I have to be always comparing to 0. So I'm going to bring the 4 to the other side. And then I need to get a common denominator so I can get a single rational term. So what I need to do is multiply negative 4, the top and the bottom, by 1 plus 2x. And then I want to combine into a single rational term. So I have 6 plus 7x minus 4 times 1 is minus 4. Minus 4 times 2x is negative 8x. So I combine like terms. 6 minus 4 is 2. 7x minus x. 8x is minus x, and that's all over this denominator. Now, because this is rational, I have to be concerned about what makes the denominator 0, and I need to exclude that from my solution. So I'm going to solve this to figure out what makes the denominator equal to 0. So I'm going to say 1 plus 2x equal to 0. 1 is equal to negative 2x. So x can't be equal to negative 1/2. So I'm going to exclude negative 1/2 from my solution. And then I need to find the 0 of the numerator. 2 minus x equals 0. X equals 2 is the other solution. Now we got to get to the last page. I'm sorry, this is... Okay, let me click out of here for a second. All right. Here we go. So on the number line, I'm going to plot negative 1/2 and 2. And I know negative 1/2 will not be included, but I have to use it when I'm creating regions. So I'm going to draw the dotted lines at 2, the dotted lines at negative 1/2. So I have 3 regions to check. Bigger than 2, between negative 1/2 and 2, and then less than negative 1/2. And we care for where it's less than 0, according to the problem statement. So for in the region greater than 3 or 2, I'm going to pick 3. A 3 will make the numerator negative, the denominator positive. A negative over a positive is a negative. Between minus 1/2 and 2, we're going to pick 0. When I plug a 0 in for x, I get a positive over a positive. That's a positive. So between negative 1/2 and 2 is positive, so we're not going to include that as part of our solution because we're looking for where it's less than or equal to 2. And then we take this final region, which is created from the 0 of the denominator. So less than negative 1/2 is negative 1, and when I plug in negative 1 into the inequality, I get positive over negative is a negative. So anything less than negative 1/2 is part of the solution. So writing that out, I would say -1/2, comma, negative infinity, union with 2, because 0 can be part of the solution as long as it's not a 0 of the denominator. So 2 with the square brackets, comma, infinity. So I hope that helps. Try to work through those problems. And as you're going through the homework, if you have specific problems that you need help with, just take a picture of them and send them to me. And then I can help you solve them. Hope this helps. Thanks.